Hi guys, this is the video for chapter 10, lesson 4. So in this lesson, we're going to be talking about inscribed angles. Okay, so remember when we talked about inscribed polygons and circumscribed polygons? That was really just talking about if a polygon was drawn inside a circle or if it was drawn outside a circle. So, when we're talking about inscribed angles, it's different from a central angle because what an inscribed angle is that the vertex is on the outer edge of the circle, it's on the circumference. So, um, you can put this down in your notes if you want to. Inscribed angle. An angle whose vertex is on a circle and whose sides contain chords of the circle. Okay, so the sides of the angle are chords of a circle. It goes from one end, one side, one part. The end points are on the edge of the circle. Okay. So, something that's kind of interesting about inscribed angles, if I named this A, B, C, here's my center, is that an inscribed angle is usually is not usually, it's actually always half of its intercepted arc. Okay. So that means angle A is half of arc BC. Okay, so I'm going to add that little note right here. An inscribed angle is half of its intercepted arc. And really what that means is just the arc that kind of corresponds with that angle. BC is the intercepted arc of A. Okay. And so knowing this truth, if I gave you the arc of BC, and I said the arc of BC was 55 degrees, then to find angle A, that would just be half of 55, right? And so what would that be? 28, 20, what, 27.5? Okay, so angle A would be 27.5 degrees. Okay, so let's take a look at your study guide. Excuse me. All right, so we've got a few angles here. Now, if we know the inscribed angle, then we can find the arc, right? So the arc is double what the inscribed angle would be. So arc AC is 72 degrees. Arc N is half of 62, so that would be 31 degrees. And then looking at arc QSR, that's half of 113, right? So that would be 56.5. Right? So 56.5 degrees. Okay. All right, let's go back to our notes a little bit. Hopefully you're writing this stuff down. So now we're going to talk about two inscribed angles that kind of intersect. So I'm going to draw an inscribed angle here from the edge going this way. Then I'm going to draw another inscribed angle. They have the same arc, but a different inscribed angle, right? So let's say that I have A, B, C, and D. And if you think about it, you've got inscribed angle B and inscribed angle C. So if two inscribed angles of a circle intersect at the same arc or have congruent arcs, then these angles have to be congruent, right? Because if I know that this arc AD is 100, then B is the inscribed angle of AD. So angle B would have to be 50 degrees. And C would also be the inscribed angle of AD. And so that would be 50 degrees as well. So these two angles are now congruent. So that's just a truth that we know. If they have the same arc, then they have to be congruent. So using this logic, let's work through some problems on our study guide. So we've got some algebraic equations now we have to solve. And we've got angles T, W, U, and V. So number 4 is saying find U. That means that U and V are the congruent angles. And so if V is 30, what would U be? Well, we don't even have to calculate. We can just know that those are congruent. It's 30 degrees. Okay, looking at number 5, T. So we know that these two angles have to be congruent and they are sharing arc UV. They didn't give us the arc, but they gave us the angle of W. So if I know W, then I have to know T. However, it's in a algebraic expression. And so, well, I know that angle W is congruent to angle T. So whatever W is, 2x plus 9, that has to be equal to 3x plus 4. Now be careful that you don't just find x and stop there. It says find angle t. So you have to use x to actually find angle t. So let's work this out. We're going to subtract 2x on both sides, minus 4 on both sides. This becomes 5, and this becomes x. So x is 5, but I'm not done. I need to plug that back in. So 3 times 5 is 15. 15 plus 4 is 19. So angle t is 19 degrees. All right, looking at this picture now, angle A. So you need to identify which two angles are congruent. A and D are the congruent angles. So make sure that you set those up as equal, not A and B, not A and C, right? A and D are congruent. So 6y minus 2 equals 5y plus 8. Work this out, find y. Y, I think, looks like it equals 10, but I'm not done. I need to plug that in. So finding angle A, plugging it into the expression, 6 times 10 is 60. 60 minus 2 is 58. So angle A equals 58 degrees. Now angle C. So I know C and B are congruent. So I'm going to set those up as equal. 6x minus 3 equals 7x minus 11. Work it out. Plus 11 on both sides, and 8 equals x. Okay, so plug that in. So what are we looking at? C. So 7 times 8 is 56. 56 minus 11 is 45. 45 degrees. Hopefully I did that right. We can double check, right, by plugging it into our next one. 6 times 8 is 48 minus 3, 45. So that works. Yeah, they should be the same. So 45 and 45. Good. Okay, let's take a few more notes. And the next thing we're going to look at are inscribed polygons. Okay, so we've actually looked at inscribed polygons a little bit, but we're going to really focus on that today. So let's add this to your notes. An inscribed polygon, as we know, is a polygon drawn inside a circle. So here's a few things that we want to know. If you have an inscribed triangle and the hypotenuse is the diameter of the circle, so it goes through the center, or if one of the sides of the triangle is the diameter of the circle, you are guaranteed that that triangle is going to be a right angle. That's just something that we see. Anytime that hypotenuse is the diameter, doesn't matter where I draw my circle. I could draw it here, and I'd connect my thing, and that would be a right angle. See that? So let's write this down as just like a truth that we know now that kind of is consistent. And inscribed angle of a triangle let's see, let's write it a little bit better than what's on your study guide. If an inscribed triangle intercepts a diameter or semicircle, then it is a right triangle. So really what that's saying is if your inscribed triangle ends up having a diameter or creates like a semicircle, then this triangle is a right angle. So that can help us solve missing angles if needed. And then another thing we're going to take a look at are just inscribed polygons, specifically just quadrilaterals. So here's a circle, and I'm going to draw a quadrilateral. And I'm literally just randomly drawing it. I'm not trying to draw a square or anything, but let's see, draw like that. Okay, so I'm just drawing a quadrilateral that's inscribed. All the vertices are on the edge of the circle. Now, something that's true about an inscribed polygon or quadrilateral is if a quadrilateral is inscribed in a circle, then its opposite sides are supplementary, okay? So that means these opposite sides of the triangle, of the polygon of the quadrilateral have to add up to be 180 degrees. So A, B, C, D. Angle A plus angle D equals 180. Angle C plus angle B equals 180. And that's something that's just true about these inscribed quadrilaterals. So let's go back to our study guide and practice this a little bit. Okay, so the first thing we're going to look at are some triangles. Now, both of these triangles intercept at the diameter. And so we can assume and know that this angle is 90 degrees. This angle here is 90 degrees. And we know that the sum of all angles of a triangle add up to be 180. So we can use that to our advantage and say, okay, well, if I know that this is 90, then I'm going to do it over here. 90 plus x plus 12 plus x equals 180, and I can work this out and solve. So I could even take off these parentheses because it's all addition. So x plus x is 2x. 90 plus 12 is 102. Subtract 102 from both sides, and you have 78. Divide by 2, and x equals 39. Okay, so x equals 39, and that's it. You're not looking for the angle, you're just looking for x. Now, number 2, though, says find angle W. Okay, so then we're going to have to plug in 39 in place of x. 39 plus 12 is angle W. So when I add this, it's 41. So angle W is 41 degrees. Okay, number 3 and 4, why don't you guys try that out? Pause it and try it out. So number 3, 2x plus 4x minus 6 plus 90 degrees. Don't forget about your third angle equals 180. This is like the third angles theorem that we know, right? And this would be 6x plus negative 6 plus 90 is 84 equals 180. Subtract 84 on both sides. And I believe it's 96 as your answer. Divide by 6. X equals 16. Okay, so x equals 16. Now angle T, we have to plug 16 back in. So 16 times 4 minus 6. Plug that in and that's your answer. Okay, down here, we've got your quadrilaterals. So here's the cool thing is we know opposite angles have to be supplementary, which means angle R plus angle P have to equal 180. So 3x plus 75 equals 180. And I could work backwards. 180 minus 75 is 105. 105 divided by 3 is 35, right? So x is 35. Now x is 35. I know I'm running out of room. You might not want to do this on your paper, but I'm not done because it's asking me to find angle R. So I have to multiply that by 3, and that would be 105. So angle R is 105 degrees. And if you work it out and do 105 plus 75, that ends up being 180. So that works out. You can confirm that. Okay, angle S, 110 plus 2x are supplementary. So I'm going to subtract 110 on both sides. I'm going to subtract my like terms. And I've got 70 degrees, divide by 2, and that's 35 equals x. I'm not done because I need to plug it in and find s. And so s, 2 times 35 is 70 degrees. Same idea down here. So practice that, do the same thing, and you're good to go. All right, that's all I have for you guys.